So let's do a hard stop because this is generally not how, biochemists will learn about what oxygen is. What do you need to know about oxygen that makes it really unique on Earth? First thing is oxygen is an electrical stressor. So I think most of you know that when you see electricity in the sky during storms, you understand that. When you see a bolt of lightning hit the ground, it makes an electrical pattern on the ground. And that pattern that it makes is electrical resistance. Okay. So oxygen also happens to be extremely electronegative. It's the second most electronegative thing on the periodic
Mhm.
table. What does that mean? It draws electrons to it.
Yeah, that's why it's the electron acceptor in the
Right.
mitochondria.
And that's what's really important. But as the electron acceptor in mitochondria, it also means it did something else. It quantized metabolism, meaning that when we began to use oxygen, we stopped using glycolysis, gluconeogenesis. We started to favor the TCA cycle. Now, the TCA cycle is a relatively new member that shows up from the Cambrian explosion on. What is the TCA cycle all about? When you go from the Cambrian explosion to us, you have to begin to use this oxygen. So what's the next semiconductor protein that life innovates, which I think most of you know? That's called hemoglobin.
And it's very
And
similar to chlorophyll in terms of its basic structure, right?
right, well, when you talk about its basic structure, this is the key part that I think where biochemists begin to shit the bed. Everybody knows that it's in the same ring structure that magnesium is in, but you know
Yeah.
that iron has 26 electrons, so much more complex because it can absorb more light. But there's something very peculiar about iron that people in biochemistry really don't learn about, but people in physics do. And it turns out that iron can only carry oxygen in the +2 oxidation state. When it's in the +3 oxidation state, it cannot carry oxygen. That's when it becomes met hemoglobin. Why is this a big story
Hmm.
for Nick? Well, because of the great oxygenation event that he and I just talked about. Remember, I told you we went from 1 to 21%. So what does that mean? The slope of that line was not linear.
Mhm.
Okay. In fact, it was pretty much nonlinear and chaotic, which is the reason why biochemists, evolutionary biologists still don't realize to this day why breathing and why metabolism has to be quantized, because oxygen is the reason why it had to be quantized. And it turns out that light is capable of changing the oxidation state of iron +2 to +3. This is what makes iron very different than magnesium. It is not redox stable like magnesium is. And the reason it was chosen by nature is because oxygenation levels changed. So you have one state of iron that's extremely beneficial for oxygenated hemoglobin. Then what else did nature do? There's some other radical chemicals. And there's one other thing I need to talk to you about oxygen that I got thrown off a stage one time in 2014 by Dave Asprey. Oxygen's paramagnetic. What does that mean? Oxygen is drawn to magnetic fields. So if you want to know why I told you a little while ago that breathing is quantized, you know that the FO head spins when you're using TCA cycle. That's 9,000 protons through the FO head. The FO head from Faraday's laws of electromagnetism that he found in 1851. The electron chain's got a current that goes through it that's got a 30 million volt charge. That's Nick Lane's work. This FO head spins 9,000 times a second. That's how you make ATP. Turns out that's discussed with TCA cycle dynamics. You know, as a biochemist, that's not true in glycolysis, not true in gluconeogenesis, not true in a lot of other things, but that's not important for this story. The point that I'm trying to make to you is that the TCA cycle is very selected for in a norm oxic environment. That means when oxygen is greater than 20%. Okay. So that's important. And the fact that oxygen is paramagnetic is never brought up in biochemistry. In fact, it's the only paramagnetic atom on the periodic table. Okay. And when I say that, I mean gas. So the spinning FO head creates its own magnetic field. That is the reason
Define
why
FO head for us.
The FO head is the spinning head of the ATPase. That's the fifth cytochrome.
The protein machine that makes the ATP.
Right. That's the protein that Nick Lane has spent most of his life trying to figure out all of its molecular biology and all its evolutionary history. And he, like I told you, he's coming through it this way. I'm going to tell you that all of this was determined by a quantum evolution, by what happened prior to and during the great oxygenation event. So
you're basically saying, in essence, when the oxygen level got sufficiently high, it sort of flipped all of a sudden the evolutionary pressure to use something like this as the way to make energy. It made the TCA cycle better at making energy.
Correct. And this gets to the crux of the issue where now I'm really gonna, I think, surprise you, because I would say to you, tell me what you think the flip of the switch was. Have any idea?
No.
Because I know you're a smart guy. To have the degrees you have, can't be. So this is the reason why I'm going to tell you why understanding Jack Kruse has been really hard for guys like you.
Mm-hmm.
Paramagnetism turns out to be a big deal. And as I told you, I got thrown off the stage for this, trying to tell this story a long time ago, 11 years ago in Pasadena. Oxygen being paramagnetic should make a biochemist say, okay, what in life was paramagnetic during the GOE that we don't talk that much about? And it turns out the Nobel Prize was given for that chemical in 1992. It's called nitric oxide, also a free radical. And here's the interesting thing. Do you know that nitric oxide also has a binding site on hemoglobin? And did you know, Nick, that binding site on hemoglobin stops ATP from being made?
No.
It actually stops oxygen from being carried as well on hemoglobin. So the picture I'm painting for you right now, you're beginning to see a taxi cab that nature used during the GOE as we went from 1% to 21%.
Mm-hmm.
And guess what? That quantum construction is still in you to this very day. And you'll be very surprised to hear that the story I told you before about light alone being able to change the oxidation state of iron is important. But because NO is also paramagnetic, now you have two moieties that are reacting very much the same way. The difference is nitric oxide works at a very focal level.
Mm-hmm. Yes.
Oxygenation tends to work at a very global level.
Well, and there's some interesting tie-ins here to stuff I've discussed on the podcast before. Like, I didn't know until about last year or so that there's nitric oxide stores in the skin, and UV light exposure liberates those.
Correct. So what does that tell you? That you just described the basics of the leptin prescription, given what I'm giving you. You're beginning to jump forward in the story because you just realized that if you're able to bind NO to hemoglobin, you don't need as much oxygen. And if you don't need as much oxygen, that means you don't need as much food. Because guess where all the electrons and protons come from? Food. Yes. So that's the basics of the leptin prescription. And then you begin to ask other questions, Nick. Say, well, this makes sense why God or evolution put leptin in our sub-Q fat, which makes us radically different